Welcome to Meta Affiliation. Here with you, you're with Zazibiela, and we are doing a problem taken from one of the previous exams that were written by grade 12. This is the problem for probability. Okay, how is this problem look like? All right, this is the problem that we are faced with today. Here we are told that the success rate of the Fana soccer team depends on a number of factors. The fitness of players is one of the factors that influence the outcome of the match. Okay, let us go in details. The probability that all the players are fit for the next match is 70%. So here, one, it's a fitness. Its probability is 70%. Okay. If all the players are fit to play the next match, the probability of winning, so now we have the probability of fitness. The next thing that we have now is the probability of what? Of winning the next match, of which is 85%. If there are players that are not fit, I quote, not fit. There are players who are not fit to play. So, okay, they are not fit. Players that are not fit to play the next match, the probability of winning now the match is 55%. So to analyze this information, here, what I can emphasize is that one, we know that if all the players are fit, the probability of all players being fit is 70%. And the probability of players who are not fit is a complement of those who are fit. What do I mean by a complement? Okay, let us go here. I'm going to use a tree diagram to express this information. Okay, here. Okay. I have two possibilities. Either my players are fit or my players are not fit. Okay. If they are fit, it's either they are going to win, another possible outcome, they are fit and they are going to win. If they did not win, that means they are going to lose. Okay. They are not fit, but they can win. They are not fit, and there is a possibility that they can lose. All right. So in this case, talking of players who are fit, we are told that the probability that all players are fit for the next match is 70%, and 70% can be written. Okay, here I said they can win or they can lose. They can win or they can lose. Okay, so the probability of players being fit for the next match is 70%. And if you want to convert 70% into decimals, you just say 70 divided by 100, and then it is equal to 0.7 in decimals. So here the probability is 0.7. So if the probability of players being fit for the next match is 70%, by default, the complement is those who are not fit. So in this case, it will be 0.3. Okay. After knowing that all players that are fit is 70% and the probability of them winning the match is 85%. And how to write 85% in decimals? It becomes 85% divided by 100, which is 0.85. So in this case here, I have 0.85. 5. And the probability of losing is a complement of winning. So if 85 is for winning, meaning 15% is for losing, those are the chances of them losing, provided that 70% of them are fit for the match. So meaning here it will be 0.15. Okay? Seems as if we're going somewhere. All right. Once again, they are not fit. Here, if there are players that are not fit to play the next match, the probability of winning the match is 55%, and to convert 55% to decimals, it becomes 0.55, and its complement is the probability of losing, provided that they are not fit. It will be 0.45. This is the information I have now. I have managed to chop it into pieces that will make sense in me. All right, what is the next step to do? I want to find the probability of them being fit and winning. Okay, that means the probability of players being fit multiplied by a probability of them winning, which is 0.7 times 0.85, of which is equal to, okay, I'll get back to the results. Again, the probability of them being fit but again losing the match is equal to a probability of fitness times probability of losing the match, which is equal to 0.7 times 0.15. Okay, probability of them, provided that they are now not fit but they still win the game. Okay, yeah, it's a probability of them being not fit multiplied by probability of them winning. Wow, that is nice, of which is 0.3 times them winning is 0.55. Okay, once again, a probability of them not being fit and as a result they lose, perhaps. So it's a probability of not being fit multiplied by a probability of losing. Yeah, we did expect that if they're not fit, they can lose. Okay, so in this case, they are not fit and it's 0.3 and they are losing, it's 0.45. They seems to be good players, you see. The result is not that bad. You see, if they are not fit, the probability of them losing, provided that they are not fit, is less than the probability of winning, even though they are not fit, which makes them be a good team. Okay? Now we want to come with the results of all the probabilities. The probability of being fit and winning is equal to 0.595. The probability of being fit and losing is 0.105, and the probability of being unfit and also winning is 0.1, so comma here 165, and the probability of not being fit and also result in losing the match is 0.135. Okay, let me erase this part. Let me erase this. Okay, let us go back to the question. The question says that based on fitness alone, of which is the factors that might influence the outcome of the match. Calculate the probability that the Fana soccer team will win the next match. Okay, to answer this question, this is what I'm going to look. One, here, they did win the match. And here, they did win the match. So if I can add all these two probabilities, that can be my solution for the problem that is given to me. So to cut the matter short, meaning a solution here will be a probability of being fit and winning plus the probability of being not fit but winning, of which is equal to 0.595 plus 0.165. So the result here will be okay, plus 0.165, of which is 0.76. So this is the result of them winning the next match irrespective of their fitness, or using fitness as the factors. I hope the video was helpful. Should you encounter any challenges, don't hesitate to write on the comment section. I will then reply to your queries. Thank you.